Let's talk about interfaces. In a previous lesson, we worked through the idea of using an abstract class as an inheritance technique to use in object-oriented design. We had an abstract student class that was defined with a few instance fields and concrete methods, and one abstract method called CalcGrade. Two subclasses were then developed, high school student and college student, both of which extended the student class, and then each redefined or overrode the CalcGrade method of the student class, each in a different way. Take a moment and review these examples before we continue. Here is the student abstract class. And the high school student class, which inherits the student class and overrides the CalcGrade method. And the college student class, which also inherits the student class, overriding the CalcGrade method. As we discussed in that lesson, the idea of the abstract class was that there were several methods, some of which were concrete and immediately defined right then and there, and then some methods which were abstract, where only the name of the method was stipulated, along with what it was intended to accomplish, but whose actual implementation was undefined, left to the inheriting class to articulate in its own special way. The abstract class also had data elements or instance fields that were automatically inherited by each subclass. Now let's talk about using an interface, the next step in the direction of abstractness, where all elements of the base class are abstract. No data fields exist, no definitions are provided, but only names of methods that must be defined according to certain criteria. Let's consider some real-world examples for a moment to get a clearer picture of what the idea of an interface is all about. Think for a moment about all of the different types of motor vehicles that surround you. What is common about how someone operates these vehicles? If you think about it, at the very basic level, you must be able to accelerate, brake, and steer any vehicle you operate. These actions require controls that you manipulate. Think about these controls as methods in an abstract class. The basic class might be called vehicle, and the methods are accelerate, brake, and steer. This class defines what these methods are called and what they should do, but does not define how they do it. It is up to each type of vehicle to define how these are implemented based on the design of that particular vehicle. A car would have its own way of doing these three things, as would a boat or a plane, but each would have a unique definition because each works in a different way. This type of abstract class, where processes are defined but not implemented at all, is called an interface. This vehicle interface would require that these three methods be implemented because they are essential to any vehicle's operation. This is an example of the ultimate abstract class, or interface. The person operating the vehicle is interfacing with that car, boat, or plane using these three essential control operations, common to any vehicle, and used to maneuver the vehicle in a safe and effective way. Another example of an interface is how you use almost all computer programs. To interface with an electronic device, such as a computer, tablet, or cell phone, you typically use a keyboard, mouse, touch screen, or joystick. These are interfaces that allow you to control what actions you want to happen on the device. Another type of interface is a game control console. All have similar features, with buttons that control various aspects of the game, changing direction, causing certain actions to happen, but each game is different, with different actions, and each game implements the controls according to how that game operates. In all of these examples, the way we interact or interface with the object is similar. There needs to be a common and consistent way to do this, but the ways the controls work are defined specifically by the application that is using the interface. Let's consider a very common interface that is used with most computer programs. The Java language has an interface called Mouse Listener, which contains the following methods associated with how a mouse works. Mouse clicked, mouse entered, mouse exited, mouse pressed, mouse released. All of these are common actions associated with a mouse. None of these methods are implemented in the actual interface definition, but all of them are common events for any program that uses a mouse. You click one of the buttons on a mouse and expect something to happen, regardless of the program that you are using. When the mouse icon clicks or moves over or moves away from an area on the screen, something usually happens, like an action or color change or shape change or anything along those lines. All 5 of these mouse events are common to most programs, and it makes sense to define in an interface what they are called and what they should do, as you can see here. But it is up to the software developer to actually implement what happens when the mouse is clicked or dragged or held down or whatever. Another easy Java interface to understand and implement is the comparable interface. The comparable interface has one job, one method to define. It is called compare_to. Here is the header for it and the description for it. Its one and only function is for the current object, which owns the method, to compare itself to the incoming object, which is received through the parameter list. Some aspects common to the 2 objects are compared, and then an integer value is returned, indicating how those features compare to each other. The most common results are the values 0, -1, and +1. If a value of 0 is returned, it means the 2 objects are considered equal to each other in whatever way that is determined. A -1 value means that the current object comes before the parameter object in natural order, and a +1 means the current object comes after the parameter object in order. To see this in action, let's look at the string class in Java, which implements the comparable interface, and is a good way to see how the compare_to method actually works. Let's look at a simple program that demonstrates this. Here you can see the command a.compare_to_b, which returns the value -1. This means that the letter A comes right before the letter B in the natural order of string objects, which is alphabetical order. The command Bill.compare_to_Amy returns a value of +1, which means that Bill comes after Amy in alphabetical order. Hello.compare_to_hello is pretty obvious. The 2 objects are equal, since they are identical strings, and the result is the value 0. Now let's go back to the student class project we reviewed at the start and implement the comparable interface in the student class. To use an interface, you put the word implements at the end of the class header and then designate the interface you intend to use, as you can see here. The only method in the comparable interface is the compare_to method. Any class that uses this interface is required to define this method in whatever way makes sense for this object. You can see a simple implementation here comparing the ages of the students. The first if statement checks to see if the age of the current object is less than the age of the incoming parameter object, and returns a -1 if that is the case. The else if checks the opposite state and returns a +1 when the age of the current student object comes after the age of the parameter student object. The final statement in the method returns a 0 and is reached if neither if statement is true. This indicates the 2 student objects are considered equal and have the same age. To test our program, let's go back to the test class we used in the previous lesson and modify it a bit. You can see the same four students created here: Joe, Megan, Reagan, and Sally. Joe and Sally are default objects for each class. We then compare Megan's age to the other three students, and you can see the results. When she is compared to Joe and Reagan, the result is +1, which indicates that Megan is older than both of those students. When Megan compares herself to Sally, a -1 is the result, which means she comes before Sally in age. If we change Reagan's age to 18, the result is 0, since now Megan and Reagan have the same age and are thus considered equal. Now, we modify the test class again and invoke the arrays.sort method, which is defined by Java to use the compare_to method in a sorting process. And you can see by the result how that worked. Prior to the sort call, the first output of the array was the original order, and the second is now in order by age. If we redefine the compare_to method to check the grade field, with a negative value returned if the current object has a higher grade, and a positive value if it has a lower grade, you can now see the result of the sort, listing the students in descending order by grade, with the higher grades coming before the lower grades. Now the compare_to method has been redefined to compare the names of the students. Let's change 2 of the names to better see the result of the sort. Joe is now Zach, and Sally is now Allie. In the first output, Zach comes first because he was created first, and Allie comes last because she was created last. But after the sort, you can now see the list is in alphabetical order by name. This is all just the beginning of how interfaces work. But now you have a fundamental understanding about what interfaces are in real life as well as in programming, and how a simple example works.